Greetings. Our project name is AI-DJ, which is a hybrid LLM DSP architecture for automatic music segmentation and mood analysis. And our team is Aditi Guntur, Mia Vishi Agrawal, Rupat Das, and Sabyasachi Sharma. Moving on to the problem statement. So, as we know that manual music editing requires expertise, finding energetic power, drops, etc. And there is no unified AI system that can understand the musical structure and suggest edits automatically. AIDS fills the gap. So that's what motivates us because platforms like YouTube Shorts, etc., requires fast, high quality audio editing, and our system reduces their effort by 70 to 80%. Moving on to the AIDS approach, where we have three-layer system having DSP integration, ML models, LLM capabilities, which we'll dive into introduction, which gives us an idea about how our hybrid system solves the problem. Basically, the DSP turns the audio into meaningful features, ML turns feature into semantic labels, and LLM turns label into editing instructions. Moving on to the system diagram of the system architecture overview. So we have user LLM, AIDJ pipeline, and prediction generators. So user basically gives the enters the prompt, and LLM suggests the track. In AIDJ pipeline, we have track downloader, DSP feature extraction, ML prediction. In track downloader, we fetch the track data from SpotDL or the other database which we have collected from the Kaggle, and then DSP features, there are numerous features which we have accounted in. And then finally, we generate a JSON output file. Moving on to the system definition for functionalities, we have DSP feature extraction, continuous energy prediction, discrete energy classification, mood prediction, JSON output, and LLM semantic cues. We'll get to know more about this ahead. Moving on to AI DJ pipeline. So basically, we have a user prompt, LLM recommendation is there, which suggests one or three tracks that align with the user prompt. Database check is there, which recommends the audio track based on the LLM recommendation from the database, as well as if there are no tracks, and we can go it from the spot there. Audio pre-processing is done. DSP feature extraction using MEL, MFCC, HPCP are being done, and then ML prediction model is there. Prediction JSON output is there. LLM remix planner, which utilizes semantic cues to suggest optimal cuts, editor module, which gives the final remix based on the suggestions. Overview of the pipeline, input layer preprocessing, extraction, prediction, audio editing, LLM interpretation, which we have used the Gemini API for, and the output layer. So we have three models: energy regression model, energy classification model, model classification model. Energy regression model have a range of 0 to 1 and quantifies the intensity of the music. Classifier model discretes the classes based on the low or the high energy. And mood classification model have four class of mood, which is sad, calm, happy, energetic, which captures the emotional arc of the music. Moving on to LLM remix planning, reads the ML prediction, understands the energy of the mood, and edit the file and then produce a JSON file. Moving on to the graphs, this is a genre graph, which have a variety of genres within it and the energy level being compared. For each genre, this is a PCA graph where we have PCA 1 and PCA 2 for um, genre versus energy levels. Moving on to visual analysis, we have feature correlation matrix, which help us to know about how each feature is important and which all features to consider and which all features to remove. So this is a heat map, and this is a MEL spectrogram which gives insights about how energy and mood dynamics are being changed for each audio segments samples. Moving on to MFCC versus energy levels. These are the graph where we compared different MFCCs with energy level. And these are the graph of RMS RMS, energy versus energy level, and spectral centroid versus energy level. And the result which we generated help us to know that our model is lightweight but accurate, and inference time is less than 1 second per segment, making it suitable for the real-time users. So AIDJ demo will be done by Savir.
Hi, so I'm showing you the demo for our project. So let me execute the main file. It is just the basic warning. It will ask the prompt. Let us say we want to make a 20s pop song. This will generate a remix with the songs. So first, now this prompt is going to an LLM, which will expand this prompt uh, from using our own engineered prompt. Then it is searching the songs in the database, whether the songs are there or not. And yes, these are the songs which our LLM gave. Now, the tool which we have used is SpotDL, which is downloading the songs. So currently, these songs are getting downloaded, which our LLM has suggested. So basically, in our prompt, we have added only 2 to 3 songs. So according to the user's prompts, it is downloading 2 songs only. It can we can expand this according to the user's need. Now, the songs which we have downloaded, it got downloaded from yeah, it got downloaded in the form of MP3. Now it gets converted into WAV and all pre-processing is happening. Then it goes to in our model. Then it generates some JSON files which we feed into our LLM and we get our final remix. Yeah, this is what our model generated. So this, as you can see, that everything is of the same energy levels, which is ideal for a basic remix and which some DJs learn in their schools.
Like them hot girls, them hits. I hop that shit the way I hopped up and slid. I pop my shit, now watch me pop again. I mop the floor, now watch me sweep up these M's. Savage, classic, bougie, ratchet. Savage, nigga got this shit from Tina. I'm a savage, yeah. Classic,
You
bougie,
can see transition,
ratchet.
smooth transition.
Sassy, moody, nasty. Acting stupid, what's happening? What's happening? Bitch, I'm a savage, yeah. Sassy, moody, nasty.
So yes, so these are just 2 songs which you saw in just under 33 seconds. So it cut, pasted, and remixed all things. You can do the same things for other language songs also. So language is not a barrier for our project. So yes, that is it.
That's all for the demo. Now moving to the observation, we have certain observation such as binary energy classification, which provides very strong cues for the editing, mood classifiers, emotional arc captures, as well as harmonic ratios, etc. help us to have strong predictions. Moving on to the application, there are a variety of practical uses of AI DJ system, such as automatic remix creation, emotional editing, DJ transitions, real-time adaptive music, and playlist generation. Moving on to the conclusion, we know AI DJ successfully integrated DSP, ML, and LLM and converted raw audio into meaningful music semantics, which can be used for AI DJ application. Future directions are real-time remixing, generative transition, and multiple track blending, etc. These are the references, and that's all. Thank you so much.